So our speaker today is from the University of Buenos Aires, Micaela Bellante, and her talk is named Magnetic Fabrics of the Late Silurian Villacorta Formation, Sierra de Famatina, Argentina. And we are not seeing her because she has camera trouble. So Mika, it's all yours.
Okay, good afternoon, everyone. I'm sorry about the camera. I don't know what happened. First of all, I would like to thank Florencia for the opportunity to give this talk. So thank you, Flor. So this work was part of my undergraduate thesis and involved the collaboration of Andres Cuggiati, Pablo Franceschini, Sergio Marenzi, and Augusto Rapalini. And the research took place at the Laboratorio de Paleomagnetismo Daniel Valencio in IGEVA, which is part of the University of Buenos Aires, and CONICET, which is the National Scientific Council of the country. So first of all, I will talk about the objectives of this work, the location of the study area, the tectonics, and the current regional context, and the Famatinian orogenic cycle. Then I will proceed to the geological map of the area, the description of the Villacorta Formation, and the studies and results of magnetic susceptibility and magnetic fabrics. And finally, I will go over to the main conclusions. So the main objective of this work is to characterize the Villacorta Formation not only from a stratigraphic and sedimentary perspective, but also through its magnetic fabric and magnetic susceptibility properties. And with these studies, we contribute valuable data to the understanding of the deformational history of the analyzed area. And something important is that this is the first time that magnetic susceptibility and magnetic fabric studies have been carried out on this unit. Okay, so the study area is located in the northern part of La Rioja province, Argentina, on the western side of the country, which is right here. This is in red, La Rioja province. My research focused on the Villacorta Formation, which outcrops on the western flank on the Sierra de Famatina, which is right here. And here in the red rectangle, we have the study area. So in the slide, you can see the study area marked in the red rectangle, and in the right, right here, we have a close-up view of the area. So in April of 2022, we went on a field trip to the study area, and during this trip, we examined the main outcropping units in Villacorta Creek, which is right here, as well as the Los Ojitos Creek, which is right here, where we identified the Villacorta Formation. And after this initial work, we focused on the Villacorta Formation in Los Ojitos Creek, and we collected samples from different members for petrographic analysis and obtained 2 samples for uranium lead dating on the detrital circons. And we measured the magnetic susceptibility along the Villacorta Formation, and we also make a systematic sampling along the section 2 of the Villacorta Formation in Los Ojitos Creek to analyze the magnetic fabric. So the study area is influenced by the compressional forces from the formation of the Andes, which is the largest active orogenic system formed by the subduction of oceanic crust under the continental margin. And the Andes were divided into north, central, and south, as we shown in this image right here. We have the northern, the central, and the southern Andes. The Andes extend along the Pacific margin of South America, and their geological history is defined by a complex combination of accretion, collision, and subduction process. And these events led to a highly segmented orogen where tectonic, magmatic, and sedimentary dynamics evolved over time and space, shaping the main morphostructural province of the present day, as we see in this image with all the geological provinces in our country. So the study area is located in the Famatina system in the southern sector of Central Andes, which is right here with the red circle. And the Famatina system constitutes the broken foreland, which they form as a result of the horizontalization of the subduction in central Argentina. So the Famatinian orogenic cycle was defined by Aseniola Santoselli to characterize the geological evolution of central and northwestern Argentina between the Middle Cambrian and the late Devonian and early Carboniferous. And the Famatinian arc is a prominent Ordovician magmatic belt, which is right here. And it represents a classic example of subduction-related magmatic arc that developed along the western manshirt of Gondwana during the early to middle Paleozoic. And a first episode of tectonic deformation was the oclogic phase in the lower and middle Ordovician, and a final stage, which is the Chanic phase in the middle Devonian and early Carboniferous. So the oclogic phase took place during the upper Ordovician when the Precordillera, which is an allochthonous terrain with Laurentian affinities, collided with the Famatina arc, which was active at that time. So this led to the closure of the ocean that was present, as shown in the image below. And in the first image, we see how this terrain is detached from Laurentia, is the blue terrain. And in the second image, right here, we can observe the Precordillera terrain colliding with the Famatinian arc, right here. This is Precordillera, and this is the Famatinian arc. So during the late Devonian and Mississippian, the Chanic phase occurred, which is interpreted as the result of the collision of the Chilenia terrain in western Argentina, and this event led to the formation of the Proto-Precordillera, which initially developed as an acronationary prims and later become a fold and thrust belt as Silenia moved toward the western margin of Gondwana. And the deformation continued into the early Carboniferous. Okay, so what we see in this slide is the geological map of the study area where the Ordovician Suri Formation is recognized, which is right here in green, along with the Silurian Villacorta Formation, which is right here. Together, these two formations form an anticline. And we can also see Agua Colorada Formation, which dates to the late Carboniferous, which is right here in blue. And we can see also the Permian Patkia Formation, which is in red, and Triassic Baquerano Formation here in purple. So previous studies had grouped the Villacorta Formation and the Carboniferous Agua Colorada Formation as a single unit, but in the work of Marenzi at 2020 and our observations revealed an angular unconformity between them, as we can see right here in these pictures, showing that they are actually two distinct units. And this is particularly important because the Villacorta Formation represents the first Silurian unit identified in the region. So the Villacorta Formation was defined by Marenzi at 2020, and an analysis of the unit was carried out along the outcrops in the Oitos Creek, where 5 informal sections were identified. And this sedimentary unit is mostly composed of sandstones with a small presence of phyllites and complete absence of conglomerates. The approximate thickness of these units is between 400 and 500 meters. About the age, Cesare at 2020 suggests a late Silurian age based on spore and plant fossils from the upper levels of member 5 or section 5. And in our study, we collected samples from the same levels of Cesare and analyzed detrital circons using uranium lead dating, obtaining an age of 418 million years, which is consistent with the studies of Cesare. And the paleoenvironment and the structures, well, the environment was a coastal marine with tidal action, transitioning into a deltaic environment, and the sedimentation cycle developed between the Eoclogic and the Chanic orogenies. And well, the Villacorta Formation rests on an angular unconformity above the Suri Formation, with the two formations forming a north-south anticline. So in these images, we can observe the characteristics of the members of the Villacorta Formation. Member or section 1 is composed of white quartzitic sandstones arranged in beds with cross stratification ranging from small to medium scale. Section 2 has a purple color, it's very different from the section 1, have a finer grain size and a smaller scale cross stratification compared to section 1. Section 3 is characterized by a yellow color with liaison rings present through the section, and there is also a limited presence of phyllites. In section 4, we have an ochre or greenish color and a higher presence of phyllites. And finally, in section 5, we return to a yellow color, but with less liaison rings than section 3, and well-marked tabular beds. So in the petrographic thin sections, we can observe the mineralogy of each member in more detail. And an important point to note is that section 2 and section 3 have a higher presence of volcanic and low-grade metamorphic lithics. Here we have a metamorphic lithics, and members for sections 4 and 5 show a higher proportion of feldspathium, of potassium feldspar. And it can also be observed that in the thin section, the many clasts show deformation, such as micas or some of the lithics observed. Right here, for example, is a mica deformed, and right here, the lithic. So we then proceed to conduct the magnetic fabric studies and create a magnetic susceptibility profile of the unit. And for the susceptibility profile, we were set up 31 stations along the Los Oitos Creek. And for the magnetic fabric studies, we drilled samples in section 2 of the Villacorta Formation, obtaining 14 sites and 151 specimens. And a preliminary paleomagnetic study is also being conducted to establish a Silurian magnetostratigraphy of the unit. So this is the susceptibility magnetic profile. And we can see that in member 1 has the lowest magnetic susceptibility values with a mean of 93 micro SI. And this is consistent with the lithology of this sector, dominated by quartzitic sandstones. And for minerals like quartz, magnetic susceptibility is typically close to 0 or negative, indicating a weak or almost non-existent magnetic response. Moving to member 2 or section 2, is observed a marked increase in the values with a higher mean compared to section 1. And this member is characterized by her purple color, and brownish colors. And this is suggesting maybe a higher participation of iron oxides. So the presence of these oxides, such as hematite, for example, increases the magnetic susceptibility due to the ferromagnetic nature of this mineral. In section 3, we have the highest magnetic susceptibility values in the profile. And this sector is characterized by an abundance of yellow color, brownish yellow Liesengang rings, which may form due to the precipitation of iron dioxide, like hematite or other minerals. And anything else is that this member shows strong oscillations in these values. Okay, moving to section 4, it's observed that an abrupt decrease in magnetic susceptibility with a mean of 194 micro SI. And the base of this member have ochre colors, but the results don't indicate a significant abundance of iron dioxide. So it's noted that a decreasing trend in susceptibility with stratigraphic height, along with much smaller oscillations in values. And the decreasing trend of susceptibility continues in the basal meters of the section 5 right here. So unlike the previous member, susceptibility shows an increasing trend starting from the first 25 meters at the base right here. So in sections 4 and 5, the presence of Liesengang rings is lower, and toward the upper part of the profile, potassium feldspar dominates the composition of the sandstones, which may be associated with the gentle increasing trend of susceptibility. When we examine the petrographic thin sections, it can be seen that the dominant mineralogy of the rocks correspond to paramagnetic facies, which explain the generally low magnetic susceptibility values of the Villacorta Formation. Okay, these are the results for the studies of anisotropy of magnetic susceptibility. We can see that the magnetic fabric of the section 2 of the Villacorta Formation was determined based on the anisotropy of magnetic susceptibility, and we analyzed the 151 specimens in this study. And from the total results for section 2 of the Villacorta Formation, we can observe that K3 axes are mainly subvertical in paleohorizontal coordinates, with an incipient tendency from a subvertical girdle approximately in this direction, with axis K2. Meanwhile, the K1 axis lie on the stratification plane, but show a marked clustering around this direction. So it is well known that sediments and sedimentary rocks modify their magnetic fabric when are exposed to tectonic deformation. So sedimentary or depositional fabric will typically show a well-defined concentration of the K3 axis in the vertical, orthogonal to the stratification plane, and a random distribution of the K1 and K2 axes on the horizontal plane, which is the plane of the stratification. This distribution of MagNetZ axis is disturbed if the sediments or the sedimentary rocks are affected by subhorizontal compressive stresses, So the progression of the deformation will gradually modify the fabric following the schematic steps, which are illustrated right here. So with the deformation by subornithal compression, internal deformation will tend to group the K1 axis in the direction of sigma 3, which is the direction of maximum extension, with K3 oriented with sigma 1, which is the maximum compression direction. And as deformation progresses, it is observed that K3 and K2 axes begin to arrange in a girdle pattern on a plane orthogonal to the direction of sigma 3. So if the deformation continues, the K3 axis will become subhorizontal, orienting to sigma 1. So this stage mark the gradual transition from a sedimentary or depositional magnetic fabric to a tectonic fabric in the final scenario. And the intermediate stages are often classified as composite fabrics, and they combine both the positional and tectonic characteristics. So based on this description, the magnetic fabric of Villacorta Formation can be classified as composite. So the parallelisms between the axis of the anticline affecting the formation in Los Oitos Creek and the K1 axis indicate that the tectonic deformation affecting the fabric of Villacorta Formation corresponds to the same process that generated this large structure. And additionally, the K2 axis shows a direction of approximately west-east, so reflecting a sigma 1 direction, which is consistent with the deformation produced in this area. So the angular unconformity between the Villacorta Formation and the overlying Upper Carboniferous Agua Colorada Formation suggests that the deformation that produced the tectonic overprint preceded the deposition of this later unit of Agua Colorada. And this will constrain the deformation of Villacorta Formation to the early Devonian or Carboniferous, and it will correspond to the chanic orogenic phase. And a preliminary study of the magnetic fabric of the Agua Colorada Formation is currently underway to confirm the hypothesis. So finally, the conclusions. Well, main susceptibility values were obtained for the members of the formation of the Villacorta Formation. The anisotropy of magnetic susceptibility study was conducted in 14 sites in section 2 and was able to analyze its magnetic fabric with a total of 151 oriented specimens. So the AMS study suggests the presence of a tectonic overprint superimposed of the original depositional fabric, and the marked angular unconformity observed between this formation and Agua Colorada suggests that the deformation generated the tectonic overprint preceded the deposition of Agua Colorada. So this will restrict the deformation of the Villacorta Formation to the early Devonian or Carboniferous and correspond to the chanic orogenic phase. And finally, a preliminary study of the magnetic fabric of Agua Colorada is in progress to confirm the hypothesis. So thank you so much for listening.
Well, thank you very much, Mika. I really liked the talk. It's always
Thank you.
nice, good old geology.
Thank you, Flor.
Okay, so we have time to questions. If you're still thinking your questions, I have a couple. So my first question has to do with the age Could
Yes,
you go back to your detrital circons? Oh yeah, well, I was asking something about the age of the circons.
yes, I
So
couldn't
these
hear
circons could
anything.
be div so those circons could be Devonian, right? And
Yes,
where do they come from?
Upper Silurian, early Devonian. Well, in the studies, we have um, some populations, and these circons, I mean, this is a paper, we are working on that, so I'm still figuring out where these circon come from, but I assume that they came from
So there wasn't an arc or intrusive or
yes, I mean, Suri Formation is it's marine, has pelites, but also have volcanic rocks. So maybe over there,
Hmm.
but we're still
Okay.
working on that.
Okay. Okay.
Or may
And
I say, may I add something? I don't know if somebody raised his hand or her hand.
no, no one.
I'm trying to find where to raise it and I couldn't. No, just a comment about what you ask. There are no uh, uh, early Devonian rocks, plutonic or igneous rocks close to the outcrops, but the Sierras Pampeanas is full of early Devonian plutons. And
Okay.
since the Villacorta Formation was probably deposited in a kind of somehow uh, orogenic environment, uh, it was just trapped between two main tectonic facies. It is very likely that deposition occurred at the same time that some of the uh, main uh, crustal blocks were uplifting. So some of these early Devonian, maybe even late Silurian plutons were being eroded. So
Mhm.
they're probably coming from there, but exactly from which of those,
Okay.
we don't
But
know.
they could come from the east.
Could come from the east and
Okay.
also from the west.
Okay. And the other thing is that did you did did you think an explanation for this high susceptibility interval you have, Mika?
In the profile,
Yeah.
uh, you mean that these
I don't
values?
know, mineralogically,
Uh,
pathologically, do you see any variation or
yes, in the thin sections we analyze, we see that sections 2 and 3 have more volcanic lithics than sections 4 and 5. Sections 4
okay.
and 5 have more potassium feldspar. So we believe that this variation could be affected the values of the magnetic susceptibility
And those circons, where did you get those from? In which part of your profile from Villacorta?
from the
For,
top of section 5.
okay.
And
Okay.
this was the same levels than Cesare obtained the fossils.
Okay. Okay. And the last question, well, I have like two more questions, but what did you do paleomag on this yet?
Okay, so this was part of my undergraduate
Okay.
thesis. So I did a
Just the
preliminary
MS.
study, but
Okay.
I did not investigate more than that.
The paleo. Okay.
And this is now a work of another person, which is Andres Cugiati.
Okay.
So maybe he will talk about this in another talk.
Well, a Silurian pole for South America would be interesting. And well, the last question regarding your stratigraphic, the AMS.
Here, oh,
Oh, yeah. So I mean, maybe you cannot tell from your AMS data, but I always had the feeling that Chilenia wasn't. I mean, can you have any idea, maybe from your AMS results, maybe from the geology, if you can tell how huge was that collision? I mean, I always had the feeling that Chilenia, like the terrain, Chilenia, I mean, it looks like a very huge collision in the field, that deformation, because the AMS looks, it has a tectonic overprint, but you would think that, I don't know, it's not so strong, right? So do you have opinions about if Chilenia was actually a foreign terrain that collisioned with southern Gondwana? Did you understand the question?
yes, I understand.
Okay.
I never thought about that,
Okay.
honestly, but uh, I think, how can I tell it?
Well,
I
you can
think
say in Spanish and I can translate.
I think it's been a huge collision, but I think that it's still investigate, and even there's a problematic where some some people don't believe the existence of this collision and others believe. So I think it's very controversial, but uh, I can I can talk about my results. So I see a tectonic overprint, and about the age of the Villacorta Formation and all the characteristics we see in this presentation. I think that Chilenia terrain collided, and it was a shear collation to make this tectonic overprint. I don't know if that responses your answer.
It's okay. It's okay. I was just asking about your opinion or your team
Yeah.
opinion. Okay. That's it, Mika. That's it for me.
Okay. Thank you.
If there is no more questions, we thank Mika again. Thank you very much for your talk.
Thank you.
And I think we can. Oh, sorry. Before we finish, I will share this last screen. So our next speaker will be on April 16th. And just check all our talks uploaded on YouTube. So that's it.